Hi everybody, welcome to Dr. Manny's YouTube Learnshops. This is Basic Statistics and this will introduce you to basics related to data collection. The learning objectives are basically more than, but will include explaining the two common types of data collection, 4 common methods or types of measurement scales used in statistics, and to compare the value labels to variables. So data and statistics, this is just an overview. Statistics, we already said, is the science of collecting, organising, analysing and interpreting data in order to make decisions. Data consists of information coming from observations, number counts, measurements or responses, as in possibly a survey. A population is a collection of all the outcomes, responses, measurements or counts that you're interested in. A parameter is a numerical description of the population characteristic, and a sample is a subset of that population, as we discussed previously. It's a statistic, a numerical description of a sample characteristic. So when we look at statistics, as we've mentioned previously, statistics is a discipline that concerns itself with the collection, organisation, analysis, interpretation and presentation of data. When applying statistics to a scientific or social problem, it is standard to begin with a statistical population or a statistical model. A statistic is just a number that represents an aspect of the sample. For example, if we consider one hospital to be the sample of all hospitals, then the average number of patients in that one hospital at the end of the month is an example of a statistic. Statistics can be employed in many domains. Healthcare and medicine is what we're concerned with, but others may be involved in business, physical sciences, environment, the government. They're areas where statistics can be employed. Now, data. What's data? Data is just a collection of facts, such as numbers, words, measurements, observations, or just descriptions of things. Observations, such as measurements, sexual category, gender, survey responses that have been collected. In statistics, the data are the individual pieces of factual information that's been recorded, and it's used for the purpose of the analysis process. There are 2 processes of data analysis, and their interpretation and presentation. Statistics are essentially the result of data analysis. For example, what time do you leave for work? How many bathrooms do you have? How much money do you make? When we look at population in statistics, a population is just a term that refers to a pool of people, individuals, from a statistical sample is drawn for your study. Therefore, any selection of individuals grouped together by a common feature can be said to be a population. They can be nurses, doctors, domestics. The complete collection of all the elements, such as scores, people, measurements to be studied. The collection is the complete in the sense that it includes all the fields to be studied. For example, all the registered nurses in Melbourne, Australia, or all the members of the Critical Care Association in Texas, in the USA. A sample is just part of a population. A population is what a sample is extracted from. Yeah, the worldwide population now over 7 billion. Sample data has to be collected in an appropriate way, however, such as through the process of random sampling or random selection. If sample data are not collected correctly, the data may be false, and in that sense, it may be useless. So when we look at a population and a sample, look, what's the relationship? A population, all the individuals of interest. The sample is selected from the population. The sample are the individuals selected to participate in the research study, and the results from the sample are generalized to the population. Sample from the population. Population generates the sample. So let's review. In a recent survey at a public university, all the undergraduate students, 250, were asked if they smoked cigarettes regularly. 35 of the undergraduate students said yes. So therefore, which of these two groups is the population and which is the sample? The population is the 250 undergraduate students. The sample is the 35 students. In the research process, statistics can be utilised in each step of the process, but is primarily employed for data analysis. So for example, asking the research question, formulate a theory or hypothesis, collect the data, analyse the data, evaluate the hypothesis. It generates the theory and it makes the research questions clear and unambiguous. It's hypothesis driven, it identifies what the data you want. You plan your statistical analysis before you collect any data. This is the research process. In the beginning, you define the objectives and draft the research questions. You design the study and plan your statistical analysis. You conduct a survey, study, or an experiment, which leads to data processing, statistical analysis, reporting the results. And it's the data process that normally involves a spreadsheet of raw data from Excel, for example, or SPSS, which you'll be looking at if you follow through on this lecture, and with one subject in each row and data fields in columns. So let's look at types of collected data. The data collection that are relevant to a research problem being studied is commonly the most difficult, expensive and time-consuming part of the whole project. Statistical data are usually obtained by counting or measuring items. Primary data are collected specifically for the analysis that's desired by you as the researcher, and secondary data has already been compiled and are available for statistical analysis. So types of data, you've got two types, primary data and secondary data. Primary data, as we said, fresh, first time, original, unique. Secondary, collected by others already, which you can review. Primary data has been collected using surveys, experiments, in-depth interviews, observation, focus groups. Surveys, however, are the most common. Each type of survey has advantages and disadvantages. For example, male, the lowest response rate, and usually the lowest cost. Personally administered, can probe, most costly, and the interviewer biases can influence the response. Telephone, convenient and fast. Web, fast and inexpensive. Secondary data has been compiled or published elsewhere, for example, census data. The skill, however, is to find data that is useful. The data that was probably collected for some purpose other than helping to solve the researcher's problem. So the advantages can be, it can be gathered quickly, inexpensively, and enables researchers to advance past research. Add to it. Disadvantages, look, the data may be outdated, and variation can exist in definition of terms, different units of measurement, and therefore may not be as accurate. So for example, a census underestimation could be an example. What are some of the categories of data? Data sets consist basically of two types of data, qualitative and quantitative. Data that's qualitative consists of attributes, labels, and non-numerical entities. Quantitative consists of numerical measurements and counts. So let's review. The grade point averages of 5 students are listed in the table below. Which data are qualitative and which data are quantitative? The qualitative data are the students. The quantitative data are their GPAs. Again, let's look at variables. Variables in research are any characteristic that can take on different values such as height, age, species, or exam scores. In scientific research, we often want to study the effect of one variable against another, which we mentioned previously, independent and dependent. An experiment usually, however, has three kinds of variables: the independent, dependent, and the controlled. So, reviewing again, variables can be classified also as discrete and continuous. So a variable, we said, can be qualitative or quantitative. If they're qualitative, they're nominal or ordinal. If they're quantitative, they can be discrete or continuous. In quantitative, as a numerical, they are continuous and discrete. In qualitative, they're categorical. If we look at qualitative as categorical, examples could be marital status, the political party that you belong to, your eye colour. They're defined categories. When we look at numerical, discrete, examples could be the number of children, defects detected per hour, they're counted items. In continuous, this is weight or electrical voltage, which are measured characteristics. They are continuous. Discrete variables are counted. They're numeric variables that have a countable number of values between any two values. A discrete variable is always numeric. Discrete data is information that can be counted, and that only has a certain number of values. For example, the number of people in a class, test questions answered correctly, the number of patient complaints, or the number of flaws or defects in an object. Continuous variables are measured, and a variable is continuous if it can assume an infinite number of real values. When you measure height, weight, and temperature, you've got a continuous data. For example, some continuous data will change over time: the weight of a baby in its first year of life, or the temperature in a room throughout the day. With continuous variables, you can calculate and assess the mean, median, standard deviation, or variance, which we'll be looking at as we go through this course. So let's review. What do you consider? What do you consider the variable? The number of children in the class. Continuous or discrete? This is discrete. The water temperature. Continuous or discrete? Continuous. The summation of how many times you change diapers in one day on a baby. Discrete. Volts of electricity. Continuous. The amounts of votes in an election. Discrete. Wind speed. Continuous. Quantity of eggs in a basket. Discrete. Now, value labels are not variables. Often confused. Value labels are words describing the values, which are typically numbers, and they're called labels. The numbers which can later be used in formulas are called values. You'll see this when you do your Excel or you do your SPSS. You can assign descriptive value labels for each value of a variable. And this process is particularly useful if your data file uses numeric codes to represent non-numeric categories. For example, codes of 1 for male, codes of 2 for female. Levels can be scales of measurement. Another way to classify data is to use levels of measurement which require variables to be measured. In statistics, the scale of a measurement determines which statistical calculations are meaningful. You have nominal, ordinal, interval, and ratio. A nominal scale of measurement is a naming scale. where variables are simply named or labelled with no specific order. This scale doesn't require numerical values or categories ranked by class. For example, a nominal scale could be gender or hair colour. What is your gender, male or female? What is your hair colour, brown, black, blonde, grey, or something else? A nominal scale of measurement. Then you've got an ordinal scale of measurement. And this is a scale of measurement that's got all its variables in a specific order. Ordinal, ordered. The order of variables is critical. So for example, ordinal scales could include the socio-economic status of a person, low, middle income, high income, education level, high school, Bachelor of Science, Master of Science, PhD, income level, less than 50k, 50k, 100k, over 100k, satisfaction rating, extremely dislike, neutral, like, extremely like, strong, agree, strongly, disagree. A specific order of measurement, ordinal. The next scale of measurement is an interval scale, and this refers to the order and the difference between two values which are meaningful. So for example, the interval variables include body temperature range, pH range, SAT scores, your credit rating. Then we have the ratio scale of measurement. And this is a quantitative measurement tool that allows a comparison of the intervals or differences to be recorded. It has a 0 point, which is a unique feature of the ratio scale. An excellent example of the ratio scale is the measurement of heights. Heights can be measured in centimetres, metres, inches, or feet. So let's review. Nominal data. Examples of nominal variables include genotype, blood type, city code, gender, race, eye colour, political party. True or false? The answer is true. Examples of ordinal data include socio-economic status, educational level, income level, your satisfaction rating. True or false? The answer is true. Examples of interval variables could include temperature in Fahrenheit, temperature in Celsius, pH, SAT scores, your credit rating. True or false? The answer is true. Then we have ratio data. And examples of variables could include enzyme activity, dose amount, flow rate, concentration, pulse, weight, length, temperature in Kelvin, because Kelvin has no heat or a 0 potential. Survival time. These are true for ratio data. So in summary, statistics data collection is a process of gathering information from relevant sources to find a solution to your research problem. The data collection methods are quantitative, as data is expressed in numbers and summarized using statistics to give meaningful quantitative data. In the 1940s, a guy by the name of Stanley Smith-Stephen introduced 4 scales of measurement: nominal, ordinal, interval, and ratio, and these are still widely used today as a way to describe the characteristics of the variable. Knowing the scale of measurement for a variable is an important tool to choose the right statistical analysis tool. Okay, that concludes this session in an introduction to the basics. There are 7 other parts to this basic statistics Learnshop. And remember, it is just the basics. And you can get access to a lot of other information on some of the excellent YouTube videos. See you in the next session, and if you think this has been of any value to you, or any of the other Dr. Manny Learnshops, recommend them to your friends and colleagues. Thanks, see you soon.